We're going to talk about the Pythagorean Theorem today. We're going to go over its uses, how to manipulate the equation, as well as go over its converse. The Pythagorean Theorem is useful when finding distances, especially when we're dealing with right triangles. One thing we're going to talk about in here as well is the distance formula, and this is a good example of where the Pythagorean theorem comes from, as well as where the distance formula comes from. So for today we're just going to talk about the Pythagorean theorem. The Pythagorean theorem is useful in right triangles, as well as obtuse and acute triangles as well. We'll go over those a little later, but for today we're going to talk about the right triangle. First off, in the right triangle we have two legs, and the third side is called the hypotenuse. The hypotenuse is always the side across from the 90-degree angle. And the two legs are the sides that form the 90-degree angle in your right triangle. Alright. More commonly, sides A and B are your legs, and C is your hypotenuse. So when we formulate the Pythagorean theorem, it's going to be the size of leg A squared plus leg B squared equals the hypotenuse squared. Okay, so for example, if we have a right triangle and we know that one leg is 6, the other leg is 8 units. We want the hypotenuse, so we're going to give that C. Alright, we want to determine what the length of C is. So we say that A squared plus B squared equals C squared. Therefore, 6 squared plus 8 squared equals C squared. Okay, and all we have to do is simplify our equation. 6 squared is 36. 8 squared is 64. Alright, simplify the left side. We get 100 equals C squared. And we take the square root of both sides, so we get C equals 10. So the length of the hypotenuse will be 10 units. Now with the converse states that if A squared plus B squared equals C squared, well, if I wanted to find one of the legs, okay, let's say I wanted to find A, what does A equal? Well, we want to solve for A, so we get rid of B. So we know that A squared equals C squared minus B squared. Alright, we could also say that for B. B squared equals C squared minus A squared. So if we have an example, where we don't know the length of a leg, we could say that A squared equals C squared minus B squared. In this case, C is 13 and B is 12. 13 squared is 169. 12 squared is 144. Take the square root, both sides, and you get A equals 5. So the missing leg is 5 units now. Alright, let's look at a couple other problems. Okay, similar to what we just did, we have an example where we say a triangle has the length of 5 feet, 12 feet, and 13 feet. Is this a right triangle? Well, okay, so which sides go to which? We have 5, 12, and 13. In a right triangle, the longest side is always going to be your hypotenuse. So in this case, the longest side here is 13, so our hypotenuse is 13. Okay, the other two legs, it doesn't matter. I just drew a rough sketch of a right triangle, so I could say that this is 5, this is 12. Depending on the situation, it could be different. I just drew a sketch. Okay, but we want to see if this is a right triangle. Alright, so we have to say that is 5 squared plus 12 squared equal to 13 squared. Okay, and we just did this, so we know that this is going to be true, but all we have to do is simplify our equation and make sure that we get the same thing on both sides. Alright, let's check 6, 8, and 12. Is this a right triangle? So the hypotenuse in this triangle is going to be 12, with 6 and 8 being the feet. Okay, so we're going to get an equation 6 squared plus 8 squared equals 12 squared. 6 squared is 36, 8 squared is 64. 12 squared is 144. And when we simplify, we're going to get 100 equals 144. Therefore, we know that this is not a right triangle. Other examples, more real-world examples. If the height of a table is 3 feet and the length is 6 feet, how long will the diagonal brace have to be? So if we look at this picture here, we have the height of the table is 3. The length is 6 feet. And we want to figure out what the length of the brace will be to hold up this table. Okay, so we know the two legs, we have to find out the hypotenuse. So we go 3 squared plus 6 squared equals question mark squared, or you can put it next. Okay, you can also use C because C is commonly used for the hypotenuse. So 3 squared, 9. 6 squared is 36 equals x squared. You get 45 equals x squared. So we take the square root, and the square root of 45 is somewhere between 6 and 7. I'm going to estimate here. 45 seems closer to the square root of 49, which would make it 7, as opposed to 6 would be the square root of 36. So I'm going to say this is about 6.6. 6.6 feet. Okay. You can also use a calculator if you like. We're not going to change this to radical. Keep this in radical form for the time being. Second example. I want to climb on the roof of my house. The house is 10 feet to the roof, and the ladder is 13 feet long. What is the closest I can place the ladder to the house. Okay, so here's my sketch of the house. Okay, the house is 10 feet. The ladder is 13. It's leaning up against the house. Okay, we want to find what is this distance right there. Okay, so here's our right triangle, and we have to figure out one of the legs. Alright, how far is that? Can we rest that, the base of that ladder from the house? Alright, so we have a squared equals 13 squared minus 10 squared. Okay, so we get a squared equals the square root of 69, which is approximately, say, 8.3 or 8.2. Okay, so those are examples of the Pythagorean theorem.